The first probe to reach Saturn was the Pioneer 11 probe in 1979. It was at this time that scientists confirmed that Saturn's largest moon, Titan, had an atmosphere. They knew they had to go back and visit the moon, but this time with a lander. Now Voyager 1 and 2 were already en route to Saturn at this point, and so naturally it was too late to include a lander with those missions. Thus Cassini Huygens was born, and in October 1997, it was launched into space. Getting a spacecraft to Saturn is no mean feat, as the whole trip is combating the gravity of the Sun trying to pull Cassini back to the inner solar system. So to help achieve the speed needed to reach Saturn, Cassini used planets as gravitational assists. It flew by Venus twice before returning back to Earth. Earth's gravity then slingshotted it towards Jupiter, which gave it the final push needed to reach Saturn. This alignment of planets, which allowed these gravity assists, only occur once every 600 years, so timing in this case was crucial. And Cassini really scraped past Earth on the second time round too. It was only 1,100 kilometers above Earth's surface at its closest approach. This is made even more interesting when you realize what actually powers Cassini. It is by 3 RTGs, or radioisotope thermoelectric generators. Basically, the power source comes from about 33 kgs of radioactive plutonium. It's this radioactive decay which produces the power, and even today it still produces about 700 watts. The issue with the spacecraft carrying this radioactive substance is if the scientists had got their calculations wrong and a crash landed on Earth, everybody on the planet would have been exposed to the radiation. Now, 33 kgs spread out over the whole Earth is a very small amount, but in the worst case scenario, NASA estimated it would have cost about 5,000 deaths from cancer. They put this down as an acceptable risk though, as the chances of this happening were only 1 in a million. Cassini used RTGs because solar panel technology wasn't good enough at the time for the Sun to power something so distant. With RTGs, Cassini would have a very long operational life, and it would still be able to carry on even now if it wasn't for the fact it was about to run out of propellant fuel. Cassini had numerous objectives: to understand the structure and dynamical behavior of Saturn's rings, explore Saturn's moons more fully, measure the magnetosphere of Saturn, study Saturn's atmosphere, and study Titan more extensively. This last part is where the Huygens part of the Cassini-Huygens comes into play. You see, Huygens was a lander attached to the Cassini spacecraft designed to see what was going on under the hazy clouds of Titan. Now, Huygens is the part of the mission built and operated by the ESA, the European Space Agency. The probe was only about 1.3 meters wide and weighed 300 kilograms. When it detached from the orbiter, it spent 22 days in space before entering Titan's atmosphere. The only system aboard that was active at this point was a wake-up timer, due to wake up the probe only 15 minutes before it entered the atmosphere. And when it woke up, what it saw was amazing. This video is an actual sped-up version of the 2.5-hour descent. The main mission of Huygens was actually about this descent, taking readings from the atmospheric pressure, its composition, wind speed, and so on. And because the mission was only to measure atmospheric readings, the battery life wasn't expected to last long beyond the landing. The scientists thought they could be landing on an ocean or lake, and so had designed Huygens accordingly. From what you can see though, it actually landed on what could be the bed of a dried-up lake. But this is a topic for another video. The mission for Cassini itself has been remarkably successful, as well as scientific data it's picked up over the course of these last 18 years. It's been able to provide some of the most stunning pictures found of space. I just want to showcase some of my very favorites of Saturn. And of course, Saturn's moons are beautiful in their own right too. And some very dedicated souls have even taken 1 million photos Cassini has taken to show us what it would be like to be sitting on the Cassini spacecraft. These are all real images. They've only been color corrected and enhanced and put in order to show movement. There's no CGI. It's simply amazing. So what is Cassini doing now? Before it vaporizes in Saturn's atmosphere, It's performing some very close flybys to the planet and some of its moons, getting closer to Saturn and its rings than it ever has before. Beginning on the 30th of November 2016, Cassini has repeatedly climbed high above Saturn's north pole, then plunged to a point just outside the narrow F ring, which is the edge of the main rings, and it will complete 20 orbits in total. Then, on April 22, 2017, Cassini will leap over the rings to begin its final series of daring dives between the planets and the inner edge of the rings. This is the Cassini grand finale. After 22 of these orbits, each taking 6 days to complete, the spacecraft will plunge into the upper atmosphere of the gas giant planet, where it will burn up like a meteor, ending its epic mission to the Saturn system. NASA's website states the reason for this final mission. As it plunges past Saturn during the grand finale, Cassini will collect some incredibly rich and valuable information that the mission's original planners might never have imagined. The spacecraft will make detailed maps of Saturn's gravity-magnetic fields, revealing how the planet is arranged on the inside and possibly helping to solve the irksome mystery of just how fast the interior is rotating. It will vastly improve our knowledge of how much material is in the rings, bringing us closer to understanding their origins. Cassini's particle detectors will sample icy ring particles being funneled into the atmosphere by Saturn's magnetic field. And its cameras will take amazing, ultra-close images of Saturn's rings and clouds. No other mission has ever explored this unique region so close to the planet. What we learn from these activities will help improve our understanding of how gas giants and families of planets everywhere form and evolve. At the end of its final orbit, as it falls into Saturn's atmosphere, Cassini completes its 20-year mission by ensuring the biologically interesting worlds Enceladus and Titan could never be contaminated by hardy microbes that may have stowed away and survived the journey intact. It's inspiring, adventurous, and romantic, and a fitting end to this thrilling story of discovery.